I am recording now. And this is a summary of drainage that can be, well, this is a drainage. So it's something that usually it's underneath the floor, or it's behind the walls. So we don't see the drainage system, but we notice if there is something wrong with it. Well, first, I'm going to explain drainage systems based on my experience and the issues I have had with this. So there might be other ways to do it, but well, I will explain what worked for me, and I won't explain what didn't work. Okay. For example, I'm not going to use these kind of elements. Usually, when we have different fixtures here, the sink, not the toilet, but when we have sinks or mm, washing machines, or we connect all together with this, and then with this one, from this we go to the vertical pipe or the stack. I'm not going to use this because I have had issues using this kind of elements. But in some books, or even in some houses, you will find that in the kitchen or in the bathroom, you will have like a grill. And that grill, if you open that grill, you will find something like that. And all the fixtures are connected to this element. And then from this element, we have a pipe connected to the vertical one. Okay, so that there is a way to do this, but I'd rather use this option. Okay, so let's work with a vertical stack. When we are talking about drainage systems, we talk about stacks. So we have a soil stack. A soil stack is the one that is connected to the toilet. And then we have the vent stack. So the vent stack is the same vertical element, but it goes all the way up until the roof of the building, because we need to connect this to the outdoor air, and we don't do it by going out through the facade. So we have to go out through the roof of the building. Okay, but it's important. This is the first thing we have to understand, that everything that comes from the toilet, uh, I don't like this option. Okay, so I don't like to connect the sink or the lavatory or whatever to the soil stack. And it's not a question that I don't like it. It's a question that now it's not allowed. Now we have to separate the drainage systems between the, well, there are three parts or three components of this drainage system. We have the rainwater, rain from the rain. We call these the storm stacks. Okay, so we have to collect the, if we have a flat roof, for sure, we have to collect the water, and then we have to get rid of it. But rainwater, it's something useful. It's something that it's not, it's clean water. We can use it for irrigation, or even we can make the most of the rainwater that it's on our roofs. Then we have the gray water, gray, color gray. It's the water that comes from all the appliances except the toilet. Let me see if we have a definition of gray water. Okay, gray water is the wastewater generated in household or office buildings from streams without fecal contamination. So everything that is not connected to the toilet. Okay. Water sinks, showers, baths, washing machines, dishwashers. So everything that doesn't have to do with the toilet, it's the gray water. And we have to, again, this is a water that it's not, we cannot drink that water for sure. We cannot even treat this water for human, for, yeah, so we cannot be in contact with this water even if we treat it. But we can use this water for, well, I think here we have, Yeah, for toilet flushing, landscape or crop irrigation, and other non-potable uses. Okay, so this is something that we have to take into account. First, the rainwater, it's water that can go to the river directly, and that's fine. So so we don't have to mix these waters with the toilet, with the stack that comes from the toilet. Okay, so at least we need two separate networks or pipes for this drainage system. We can connect the rainwater to the gray water. I don't recommend you do this, but we can do that. And for sure, we need a separate um, system for everything that comes from the toilet. So this is the first thing that we need to know. Treating water or making the most of the water that we have in our building, it's something relevant. I think I've told you before that in New Hampshire, it rains a lot, and when it's not raining, it's snowing. Uh, so there is no water issues. But in other countries or even in other areas of the United States, like California, they have issues with water. So we don't have to waste it. So if we want to go for sustainable design, then we have to think of systems to reuse the water that is usable. We cannot reuse the water that comes from the toilet. We have to get rid of it. But we can reuse the water that comes from the rain, or we can reuse this gray water. And why are we doing this? Well, I think you should be familiar with the LEED. LEED stands for Leadership in Energy and Environmental Design. You know that our building, the TDS Center, it's a LEED Platinum building. So here we have the scale. Okay, so we have a LEED certified building, and then we have silver, gold, and platinum. So platinum is the best. And it's well, it's a question of earning points. Okay, so there are criteria to earn points, and the more points you earn, the better your building will be in terms of this LEED classification. And well, I think we can, yeah, how LEED works. There you go. So there are different categories. This is a summary, and we can earn points in different categories. So the first category is the sustainable site. Well, if we have to work with in the middle of a city, we cannot. There's nothing we can do. But there are points if we have public transportation nearby, or we have a bike storage. Okay, so we can do this. And the second is water efficiency. So this is what I meant. We have to reduce the water used in the toilets, okay? And we have to reuse the gray water. So by doing this, we will gain points in this LEED classification, and our building will be better. And then we have energy in atmosphere. So this is about energy efficiency, CO2 emissions. We have talked about this. We haven't talked about materials and resources. Maybe this is something that we should include, but I think in the SPEEDY program, you have a course on sustainable materials. So maybe you can take that as an elective or whatever, because you will learn a lot of about why we can gain or we can achieve sustainable design by using the right materials. Okay, so I think you should take that course if you haven't taken, or maybe if you're interested in these kind of things. In architecture, we're not talking about materials, but it affects the sustainable or the energy and environmental performance of the building. And finally, we have the indoor environmental quality. Now more than ever, having a good indoor air quality is important. So that's why we need to ventilate, we need to use heat recoveries, we need to use air handling units with filters. Okay, so this is what indoor environmental quality means. And then we have innovation in design. What can we do to make our building better from the design point of view? We're not talking about appliances, we're not talking about system, mechanical or plumbing or whatever, but just we are talking about design. How can we get points by an intelligent and a good design? Okay, so this is what LEED is about. LEED comes from the United States, and now there is like well, I don't know. There are two certifications. We have the Passive House and we have the LEED. The Passive House comes from Germany, and LEED comes from the United States, from the U.S. Green Building Council. As far as I know, in New England, people or architects or engineers prefer to be aligned to the Passive House requirements, and they consider that LEED is not. And maybe it's yeah, maybe there's something true. Passive House, it's more objective. LEED, sometimes you earn points in things that don't make any sense, and sometimes you lose points because you can't decide your site. Okay, so it's not fair that because my site is not close to a public transportation, whatever, I lose points with my design. Anyway, I think it's good knowing both categories and using both because combining a good passive house with a good LEED performance, I think for sure it will be a good building. Okay, so this is LEED, but as you can see, there are points in water efficiency. So these points in water efficiency, it's about the reuse of gray water. And that means that we have to separate this. So this is not a good option. This is not a good design option because we are connecting everything. The water that comes from this basin ends up in this soil stack that comes from the toilet. I wouldn't do that. And we are not going to do that in our Revit file. Then this is probably the most important thing in when it comes to this drainage system. We need traps. I don't know who invented traps, water traps like this, but I think it's one of the most important achievements or accomplishments of mankind. Why? Well, because as you can see, we have pipes. Those pipes are empty, so they are not filled with water. The pressure pipes, the plumbing, they are always filled with water. They are never empty. And then we move that water. But these drainage pipes are always empty and there are gases. And as you can imagine, those gases don't smell like roses. And we have to prevent those gases from entering the building. And that's why we have this water trap. Okay, so you can see that underneath every single fixture, we have a water trap. If we don't see that in the toilet, it's because the water trap usually it's here, it's within the toilet. Let me show you. Okay, so this is it. So this is a toilet, and we have we can have a double water trap here, as you can see. Okay, so that makes that all these gases we have here, they don't end up going out. So it's important. So in every single section of toilets, we will have water traps. Okay, so we always have this, and then we see the water here. So you see that all toilets, they include a water trap, and then we just go down. Okay, so what we are going to see in Revit is this toilet, and then we see that as of this point, we go down, but the water trap is included here. So first, we have to make sure that our fixtures include the water traps. If they don't, we have to design a water trap underneath the fixture, anyone. So it can be a basin, a sink, a washing machine, whatever. We need water traps because otherwise there will be a terrible smell. And then this is much better. Well, this is much better. No, it's not. Because here we have two separate stacks. We have the soil stack. Soil means that it's connected to toilets. And then we have the waste stack. The waste stack is the stack, the vertical pipe that is not connected to toilets. But here they have connected everything on one horizontal element. So there is no point in doing this. So we need a waste stack for everything that it's not a toilet. And then we need a horizontal pipe. And then we need a different horizontal pipe for the soil stacks. Okay. Is it mandatory? Probably in New Hampshire, this wouldn't be, I mean, having two different drainage system for the gray water and for the toilets is not mandatory because there is no issue. There are no issues with water. There's plenty of water in New Hampshire. But even if it's not mandatory, we should be sensitive to the problem so that when we are designing something in California, so we don't know, what is this? Do we have to do this? So if we know that we have to do this even in New Hampshire, I think it's better. And this is the right thing. Okay, so here we see that everything that comes from the toilet, we need a vent stack that goes up beyond the roof, and then it goes to this sanitary sewer. And well, at least we have this storm sewer that the water from the rain is directed to this, and then we have two different sewer systems in the city. It depends on the city, of course. If at the end, if we separate the stacks, and at the end there is only a sewer system in our city, but what can we do? Oh, and this is something important. Order matters. What is below and what is above matters when it comes to these kind of systems. And for sure, the sanitary sewer, everything that has to do with the toilets, it's below anything else. Because if there is a leak, that will infect everything. Okay, so if there's a leak in this system, okay, it goes down and nothing will be affected. And if there's a leak here, yes, so the sanitary sewer system will be affected by the storm sewer. That it doesn't matter if it's the other way around. Okay, so even when we are designing this within our building, and if we have two different horizontal pipes, one for the sanitary, another one for the storm or the rainwater or the gray water, we have to make sure that always the sanitary one, the one that comes from the toilet, it's under the one that comes from the rain or from the gray water. And then, well, it's always the same. So we have this, the sanitary sewer, the storm sewer, and in the city, underneath our streets and sidewalks, we have a terrible, well, we have this. So we have huge pipes leading the waste to somewhere. Where? Okay, so we have this in our cities and those pipes are huge. We don't study this in architecture. Civil engineers, they study this. So when the sheet leaves our building, then it's not our business anymore. And then civil engineers, they have to design these city sewer systems. But as you can see, it's something huge, and we are just living happy, and we don't know that there are things running underneath our feet. And sometimes we have galleries. Okay, having galleries, it's something good, because in these galleries, we have all the city supplies. We have the electricity, we have the water supply, and we have the drainage. So it's good because if we don't have to dig a trench anytime we have an issue. When we have a link, if there is a gallery, we can access that gallery, and then we can go, yeah, we can check if something is wrong. Okay, so these galleries, uh, I don't know, it depends on the city. In large cities, they usually have galleries. I don't know in Kim if they have galleries or they have trenches with these kind of things. I think this is what happens in Kim, as far as I know. And now we need to understand we are not designing the system, the sewer system, the city sewer system, but we need to understand that everything that comes from the sanitary sewer, from the toilets, it doesn't have to go directly to the river or lake or the sea. We need to go to a treatment plant. And then once we get rid of toxic substances, then we can, yeah, we can connect this to the river or the sea. Okay, so that's why we have to separate both things, because we can get rid of the stormwater directly to the river, and I think I have seen this in the Ashuelot River. I have seen these stormwater pipes just discharging water to the river. But somewhere there should be a wastewater treatment plant somewhere close to the city, and then once we have gotten rid of those toxic elements, then we can connect this to the river. Okay, so that's why we have to separate this. If we don't separate this, we can either no, we don't have to do that. So probably everything will go to the wastewater treatment plant. But there are a lot of things we can do with this stormwater before yeah, before getting it into the river. Okay, so that's why it's a good thing to separate these two systems. And here, well, we have some tables to calculate this, and we will make a simple exercise to calculate the diameter of those stacks. With the gray water, if we are talking about sustainable design, it's not just that we have to separate both systems, the sanitary system and the gray water system. It's that we can include in our building something to filter that water or to treat that water, and then we can use that water for irrigation sprinklers. Okay, so this is something we can do. With something like this, we will gain points in that LEED category. So I recommend you do this, even if it's not mandatory. In other countries or in other areas of the United States, this is mandatory, especially if you want to have a green grass. So there is no point on irrigating the grass with drinkable water. There is no point in doing this, especially if we don't have enough water to drink. Okay? And yeah, and everything that comes from this, well, it depends. We can have different treatment plants. There are treatment plants, and we can get water, drinkable water after this treatment, but it's too complicated. So I don't think we can do all of these filters and chambers and in buildings. So we can have plants, treatment water plants. I think okay. So there are huge facilities outside the city, and here those are the water treatment plants. So this is an industry, and we can turn especially the storm water and the gray water into potable water. We can't do that with the water coming from the toilets, but having something like this in a building, I think it's quite complicated. Okay, but in our cities, there should be something like that. There should be plants like this to treat the water, and we have different tanks, one for the gray water, another tanks for the sanitary system, and then we can, okay. Anyway, those are industrial facilities, and there is no point in having something like that in our building. But at least small devices to turn this gray water into something that can be used for irrigation, I think it's a good option. And then, especially when we have flat roofs, we need drains. Okay, so this is something that we have to take into account. When we have a roof with a slope, we get rid of water and that's it. Sometimes we have a gutter. Okay, when we have a roof that is not a flat one, we have gutters, and then we have this rainwater stack that connects this water to the storm sewer system. But this is easier, so that's why having water outside the building, it's always easier. But when we have flat roofs, then we need to get rid of water, but the water has to go through the building, and then we have to get rid of it. And depending on the area of the roof, we have to place more or less rainwater stacks. How many? We will find out on Thursday. But remember that we have at least 3 categories. We have the waste stack, we have the soil stack. The soil stack is the one that comes from the toilet. The waste stack is the one that doesn't come from the toilet. And then we have the rainwater stack that comes from the rainwater, especially if we have a flat roof. Okay, so there will be like 3 different stacks in our buildings, and it takes up a lot of space. We saw that in the plumbing systems, the diameter of the pipes were ½ inch, 1 inch, 1.5, something like that. The minimum diameter for drainage pipes, it's about 2 inches, the minimum. Everything that comes from the toilet, the minimum, it's 4 inches. Okay, so if we have a toilet, we have 4-inch pipe that goes out of the toilet. And if we connect 3 or 4 toilets together, then we have to increase this. So we will end up having stacks with 6, 8 inches. So it takes up a lot of space. So that's why we need to plan. It's not something that we are going to show, so it's not something beautiful. But if we don't work with the right space, there will be issues with it. And okay. So if you remember this is the TDS center. I told you that always we have this double wall with an air cavity here where the toilets are. Okay, so we will use this element, or we will use this space to place our stacks, the rain stack, the gray water, we will use this. Or I don't know, for the sinks here you see that we have another double wall. Here we have another shaft Okay, so when we have a shaft here, we can have air ducts, and sometimes we can have stacks and water pipes. Okay, but at the end, we are using a lot of space. Here we have this janitor room, and I'm sure that there would be some pipes in this janitor room, that especially those that come from these sinks here. So I'm sure that there will be like another stack here. So in this, there are 3 toilets. We have 2 urinals. So all these will be connected to a vent stack. I think we should place the vertical stack here. Why? Because the closer to the toilets, the better. Okay, so if we have 2 urinals and 3 toilets, I would place the vertical pipe here because it's closer to the toilets. I wouldn't place the stack, the vertical one here. And then from those, I wouldn't connect, well, we don't have to connect this to the soil stack because we want to separate the systems. We have one for the toilets and a different one for the, and I think since we have this janitor room here, I think we should have pipes here. And for the ladies, yeah, I think we have this somewhere. Well, here, I don't know. It can be either here or there. I don't know. And for the sinks or the lavatories, I think, yeah, there would be a stack here. Let's do it. Okay, we are going to use this. We planned the water supply system, and now we have to work with the sanitary system. If we look at this, we have 3 toilets, 2 urinals, 4 sinks, first floor, second floor, and we agreed that, well, I agreed to myself with myself that we are going to place the stack, the soil stack here, okay, close to the toilets. So we need a pipe that goes from these 2 urinals up to this point, and then from the sinks here, we will go this way, and then we need a stack somewhere here, and then we can go down. Okay, let's do it. This is quite easy. Once we are working with this, it's as easy as the plumbing system. Pipes are bigger, that's the only concern. And there are other things that we have to, so there are other fittings that we have to upload. If you see here, we don't have a T, so we have this element. Okay, so let me show you. Okay, there you go. First, what is the material? You can find lead. I mean, if you are working with a building that was built 100 years ago, you can find the sanitary system made of lead. It can be made of cast iron, or it can be made of PVC. And now the option is PVC. It's a plastic. It's not affected by corrosion because other metals are affected by corrosion, and eventually we will have to change them. So PVC plastic is PVC. That stands for I think it's polyvinyl. Yeah, polyvinyl chloride. It's a polymer. It's plastic, but it's the right option for this. And we have to upload those families. And as you can see here, we don't have a T, so we always we need to help this movement because we have to go down. if we had a T, so you see that in all these fittings, we have this curve, or we help the water and the things that are floating in the water going down. Okay. Yeah, so this is it. So we have to upload all these fittings in our pipes. I think the best option is the plastic or PVC, or is the best option. So let's do it. First, we have to insert, where is it? Insert family, and in pipe. Okay, so it's not in plumbing, it's in pipes. In fittings, we have the carbon steel, but we have PVC. Okay, so you have to open PVC, and let's insert everything. There are two folders, this one, and this is slightly, well, we have a lot of elements here. I don't want to think about it now, so let's load everything into the drawing. Takes time. There you go. Okay, so I think now we're good, and we can start designing this. So those are the toilets. We assume that the toilet includes a trap here, and those are the urinals. I don't think the urinals will include a trap, so we will design a trap for the urinals, and we will design a trap for the sinks as well. Okay, so let's do it. I think if we open this from the east elevation, okay, there you go. So if we select the toilet, you see that here we have this create pipe. Okay, so there are different points here. So this is for the plumbing system, and this is when we have something like this is for the drainage. And here we even have the fixture units. Designing this system is about fixture units again. So we have the water supply fixture units for the water supply system, and drainage fixture units for the drainage system. But now we are familiar with this concept of fixture units, so we have the same with this. Okay, so let's draw pipe. We can go down, and well, let's be careful, because now we can't have intersections between the plumbing and the drain. Okay, so make sure that they are not in the same vertical, because otherwise there will be some issues. Okay, so this is the first pipe, and as you can see, this is a 4-inch pipe. It can be even bigger. By default, we have a 4-inch, but depending on the toilet, we can have up to 10 inches. Okay. So this is a 4-inch, the one that goes that comes out of the toilet. It's a 4-inch pipe. What can we do now? Let's open the other elevation. Yeah, okay, so we have this here, and now we can copy this, copy multiple. There you go. Okay. now we need something that goes out from the urinals. So we can draw pipe. Okay, the one that goes out, it's a 2-inch pipe, as you can see here. 4 inches for toilets, 2 inches for urinals. So let's draw another one. And now we are going to insert the trap. So you click systems, fittings, pipe fittings. Now we have all the things that we have inserted here. And there should be a trap somewhere. So this is a trap. Okay, so this is a standard PVC trap. So let's click on it. And let's insert it. There you go. I don't think it's the right direction because on this 3D, okay, so it's facing the wrong way. So I think we can rotate it. There you go. We rotate it. And now from the east elevation, it goes well. Here we have the trap. Okay, so we have designed the trap for this, and we assume that we have a trap here within the toilet. And now we need, we need to connect all these to a vertical pipe here in this corner. How can we do that? Let me see, level 15. East elevation. So let's draw a pipe. Okay, so now they are in the same line. And we can go down. Okay, so now but this is not what I want to do. Okay, so it has been connected and that's fine, but it's not what I want to do. Okay, so I'll drag this here. I don't want this elbow. I'll drag it here. And this. So now from this, okay. So when we are starting a horizontal element, it can be like this. Well, maybe it can be better, but at least this is connected. But then after that, we have to make sure that we have this this fitting. Yeah, something like this. Okay, with this curve here. So it's not a T. If we just connect this to this, we have a T. And well, this is not the kind of fitting that we want here. So that's why now from the south elevation, we can move it here. And when we are connecting a vertical one to a horizontal one, instead of going like this with a perpendicular angle, I will draw pipe. So you have to do this with a 45 angle. So we do this with a 45 angle. Nice. So we have this connection. And this is better, okay? Because we are connecting this in this direction. It's not a T. We are connecting this, especially the second, the third, the first one, it doesn't matter because it goes like this. But if we had a T here, maybe that flow will either go this way or that way, and we want it to go that way, okay? So that's why we have to make it, okay? So by doing this, we are sure that this flow will go in this direction. And that's it. Okay. And now we have to connect this to these pipes, and the pipes here, at least they need to have 4 inches because this is a 4-inch pipe and this is a 2-inch pipe. Okay, so we need a connection. We can use this level. We can draw pipe. And for this, I'm going to do the same. Okay, so I'm doing this. This is not what I want. I don't want this kind of T's. So I just delete this. And I don't want this elbow here. I delete this and delete this part of the pipe. Okay, so before the first toilet, I need to make it bigger because I cannot connect a 4-inch pipe to a 2-inch pipe. Doesn't make any sense. So now I can connect these 2 to these 4. Okay, so I have done this. And now for this, I will connect this with a 45 angle. So first I will make this shorter. And now draw pipe. Well, if it's 45, is it 45? 45. There you go. Okay, that's much better than working with the T. So now we have this, and we make sure that the flow is in this direction. Okay. Now at some point we need a vertical pipe, so we can draw something vertical. Remember that for the vent stack we need to go beyond the roof level, and here we don't need an elbow. I have to delete this, and I have to go down, all the way down, underneath the floor level, because this is there will be horizontal pipes, and there will be buried. And I told you that the gray water should be above this level, so I'm going to make it a little deeper. And now this, I don't like it because I think it's too close. So I'm going to, yeah, because from this point, I want to draw a pipe with this 45 angle. There you go. Okay, so this is important, having this angle here. Okay, now it's a question of calculating things. We have done this with, I think this is 4-inch. If we are connecting 3 toilets, most likely this won't be 4-inch. And by the way, well, let's talk about this. So here we are connecting 3 toilets going down, but this is the vent stack. So there is no thing, there's nothing going up. So probably this one should be bigger, let's say 6 inches. 6. Okay. And yeah, I think this will work. Okay. Now I think we can copy all these because the first floor should be the same. Yep. And now we have to connect this to this pipe. So on the south elevation, no, not on the south elevation. Yeah. Well, look at this. If I don't have enough distance, something weird will happen. So I need to make this longer. And then I need to, with 45, there you go, that works well. And then on level 0, oof, it's a mess here. Yeah, be careful because this is not connected yet. Hmm. There you go. Okay, so it's quite good. So now we are done with the soil stack. We have connected all toilets and the urinals to the same vertical pipe. It goes underneath the floor level. It goes above the roof level for the vent. So now it's working well, and this is all we need. And now we need another stack for the sinks. Okay, so let's do it. The sinks on the south elevation, we have the sinks here. So this is the drainage. Let's draw a pipe. Oh, and sorry, because now we need traps. Yeah, because for the sink, we also need a trap. So let's insert another fitting, another trap here. And we have to rotate it. Oh, it's here. It's on the first floor. And well, the trap is just the other way around. So we have to rotate it again. There you go. Now on the east elevation, again, make sure that we are not in the same vertical. So we have to go beyond this wall, and now we are not in the same vertical. And I think we can copy all these now. One, two, and three. And now we can go that way. Okay, so you see that we have the same issue here. We have the T's, but we don't want T's. So we need go. And now probably the distance here is too short for the 45-degree. Okay. Draw pipe. Sometimes if it's not 45, it has to be 135. Okay, so it can be either 45 or 135, but the angle is important. And now finally, we have this one, 135, and the angle is there. And now, yep, this is it. And what is the size of this pipe? It's 1/1/2. Okay. So now we can go up, and then we can connect this to the vertical pipe. We should go in this plan. We should go out of this. We are with this line now, so we should go up to this point, and then the vertical stack will be here. So let's do it. And from the south, yeah, this is it. Let's go this way. Draw pipe, and we'll go all the way up because we need another vent stack. We don't want this elbow. We go down. And this is what I mean. Now we have to make sure that everything that comes from this, everything that it's gray water, it's above the sanitary system. Okay. And we have to connect this. With 135. There you go. And now we can copy all this. Here. And finally connect this. Okay. So we are done with it. I think this is well, there are good decisions here because we have connected all the toilets to this one. We have connected all the sinks to that one. We have vent stacks here that go beyond the roof level. And then now we would need a horizontal, yeah, so we have to get rid of it. So we have to draw a horizontal pipe. And from this one, we need to draw another horizontal pipe. Okay, so this is buried. So those lines, this is the gray water, and this is the soil stack. They don't have to be parallel, so we can. Okay, so we have to work with this depending on, and probably if there is another if there's another toilet, and at the end we have to connect all the toilets to the same system. So make sure that every time we connect to horizontal pipes, we also have these 45. Okay, so if this is coming from the ladies' toilet, that would be somewhere. So this is the men's toilet. The ladies' toilet will be here. So there will be another vertical stack, and then in the horizontal, we will connect this way. Okay, but it doesn't have to be parallel or perpendicular or beautiful, because well, the only thing is that every time we connect this and this, we have to make sure, because this the angle of this fitting, it's 45 degrees. We might find other angles, but 90% of these fittings will be a 45-degree angle. So that pipe and that pipe, the angle between these two pipes should be 45 degrees. Okay, and now we have to make sure that the gray water system is above this level. That's the only thing we have, and that will be what do we have at the end? Yeah, so we get rid of it, and there's some point, our building ends at some point, and then we have the city sewer system. What do we see? We see a sewer cap. Yep, this. Okay, so somewhere in the sidewalk, or in the middle of the road or the street, we will have this sewer, and everything that comes out of our building, we have to connect it to this sewer. If we have a long building like the TDS center, again, probably we will have to connect these to different sewers that we have in the Winchester Street. I don't know if we can. Okay, so this is the Winchester Street. This is the TDS Center. Well, we can see where the sewers are. There are some caps here. So I don't know, probably it goes out of the building and then it goes to the Winchester Street, or maybe there are some connections from the toilets to the Winchester Street. I don't know. But I'm sure that if you walk this sidewalk, you will find street sewer caps like this. And this is the first thing we have to do when we are designing a building. We have to find out where those sewer systems are, because this is important. If we I want to find okay. So this is the first thing we are when we are designing a building. The first thing is the slab. Okay, so we have a structural slab, and this is the foundations of the building. But even before the foundations, we need to localize where the stacks are going to be, because they are buried. Okay, so this is the first decision. It's not the first decision. It's the first thing that the workers are doing when we are starting a building. Even before the foundations, we need to place the horizontal sewer system. And then we need to place the vertical pipes, because as of this point, we will start doing the vertical pipes. Okay, so it's important because it's the first thing. We don't care about it, but if we don't do it well, okay, so usually we have the foundations plan, and in the foundation plan, we have to place all these pipes, and they will be buried, and you will forget about them. So you will only notice that there is something wrong with it, but there's a problem, and what happens if there's a problem with the sewer system? Uh, you don't want to know it. It's a real problem. Okay, so sometimes we have elements like this, so that if there's a problem, we can open this cap, and then we can find out what the problem is, what pipe is giving us this problem, because it's buried, and it's impossible to find out where the problem is once it's the concrete is casted here, and uh, but yeah, so here you see that before casting the concrete, we have all the PVC pipes here, and here we have the starting point of the vertical pipe. Okay, so we have to design this carefully, because otherwise we cannot do it afterwards. So we cannot have the building and the foundation say, oh, I didn't design the sewer system. What can I do now? Nothing. You have to do it beforehand. So it's the first thing that you have to do when you are in the construction process. Okay, so depending on that building, and if we want to analyze, if we have different bathrooms, imagine that somewhere there is another bathroom in our building. So what do we do? Do we connect this to this, or do we have to go out of the building that way? Because there's another cap here, and then there's another one there.